Hi, this is episode 46 of Crondos. I'm your host, Jordan Hudgens. I'm a Ruby dev and the CTO of the DevCamp platform. On Mondays, I cover computer science topics and walk through a dead simple explanation on how it works. Today, I'm going to give an object-oriented inheritance tutorial. First and foremost, let's talk about what inheritance is as it relates to object-oriented programming. At a high level, inheritance allows you to extend the functionality of classes in your code. We'll begin by reviewing a real-world example of a poorly written feature. I'm going to use a Ruby programming language for this example. However, inheritance works pretty much the same across most programming languages. Here we have an invoice class that, for the sake of this example, simply prints out a summary of the invoice. The class encapsulates a total, customer, and category value. Additionally, the class has a summarize method that calls these values and prints them out. As far as a traditional class goes, this invoice class works perfectly fine. However, as it usually occurs, what happens if you're asked to build a feature for printing out a shipping label? If you don't use inheritance, then your code may look something like this. With the new shipping label class, we need a total and attribute value. Additionally, we're printing out a label that contains the values from the class. There are a number of issues with this implementation. The most glaring is that the invoice and shipping label classes have almost identical values. By creating two separate classes, this code is breaking the DRY, which stands for Don't Repeat Yourself principle. If the requirements change where invoices and shipping labels need to both print out an address, city, state, postal code, etc., you'll need to add identical attributes to multiple places in the application, which is a really bad way of writing this program. Eventually, this type of application design would lead to a very convoluted code base that would be nearly impossible to maintain. Don't worry though, this is where the principle of inheritance comes into play. In order to refactor this code, we're going to perform two tasks. One, we're going to use inheritance so that the shipping label class will be a child class of the invoice class. Second, we're going to refactor the invoice class so it's more flexible and will work better as a parent class. Using inheritance in Ruby is relatively straightforward. In our class definition, we simply declare that the shipping label class inherits from the invoice class as shown here. As you can see, by having the shipping label class inherit from invoice, we're able to remove the initialize method and associated attribute declarations. This implementation has removed the duplicate code we had earlier, so it's looking better. However, there's one issue with our program now. If you notice, when we create a shipping label, we need to add in the category because the invoice class requires it. However, it'd be a poor design decision to require shipping labels to be instantiated with an attribute that they don't actually need. With this in mind, let's move on to refactoring the invoice class to make it more flexible. Most languages have the ability to declare that some attributes in a class can be optional. As you can see in the code, I've removed the category from the attribute argument list, and now it's simply an optional value. With this implementation, when we create a new shipping label, we don't have to include any values that would be unnecessary. For further reading on inheritance, I highly recommend Practical Object-Oriented Design in Ruby, an Agile Primer by Sandy Metz, and I've included a link to it in the show notes. I hope that this has been a helpful object-oriented inheritance tutorial and will help you to improve your code design decisions.